Okay, this is a quick video on interval notation, and we'll talk a little bit about solving inequalities and absolute value inequalities. So first of all, a lot of you are familiar with inequality notation. So if you have like 3 is less than or equal to x, which is less than 5, that means you're talking about all the numbers between 3 and 5, including 3 but not including 5. So the way you'd write this in interval notation, so interval notation would be you'd put a hard bracket here because it's less than or equal to, and put the 3, 5, and then a soft bracket. So a square parenthesis, I guess you'd call it. I don't know what these things are called officially. Means that you include the endpoint, and round it off like a normal parenthesis means you don't include the endpoint. So this would read just like that. This is all the numbers between 3 and 5, including 3 but not including 5. Okay, so that's interval notation. So if this was both equal to, then this would be a square bracket like that. If you took the less than or the square off of that, then these would both be round. Okay, and if you have to do more than one, let's say that you have all the numbers from 3 to 7, and then from x, let's see, or x is greater than 10. Okay, so that would be soft bracket for 3, hard bracket for 7, and then we put a little union here, and then this would be from 7 to infinity, and you always put a soft bracket on infinity. Whoops, not 7, that should have been 10. Sorry, 10. Yeah. Okay, so that's interval notation. And I want to talk a little bit about solving inequalities with absolute value involved. So for example, if I have the absolute value of x plus 2 minus 7 is less than 10. Okay. Well, your first move is to get the absolute value by itself. So you notice that minus 7 on the outside. I would add 7 to both sides first. Then you'd have x plus 2 is less than 17. And now this is where you have to think about what absolute value means. Remember, this is basically saying that the distance from 0 is 17 of this thing. So x plus 2, that means that x plus 2 on the number line is between negative 17 and 17, because that would be the distance is less than 17. So then we have to say that in two separate inequalities. We would say x plus 2 has to be less than 17, and at the same time x plus 2 has to be greater than negative 17. So that would describe, that's what this is describing, that if you think about the number line, here's 0, here's 17, here's negative 17. So to say the absolute value of something is less than 17, it means it's in this area right here. And notice that that describes that area. Okay, so then we just solve both of these. So that would be x is less than 15, and this would be x is greater than negative 19. So then if you were to graph that, you'd draw your number line, and you'd do, here's 0, here's negative 19, here's positive 15, and because it's a less than, strictly less than, we put an open circle there, and we draw the connecting line. Okay. Now I had an email from someone that was discussing this, that just using your common sense, if you see something like this, x minus 2 is equal to negative 5, we know that this would be no solution without even doing anything, right? Because we're saying the absolute value of something is equal to a negative number. That's impossible. So this would just be no solution. Likewise, if you had if you had less than -5. That would also be impossible. There's no way an absolute value of something could be less than a negative number. However, if it was greater than, then you could say that all real numbers work, because no matter what you plug in for x, an absolute value of something is going to be greater than a negative number. So that's just a quick little kind of special cases that it was brought up in a discussion with someone else, so I thought I'd point it out to everyone. So let's see, what else did I want to say about this? So the main thing is I wanted to make sure you guys understood interval notation and some of the absolute value. So when there's stuff on the outside, we want to get the absolute value by itself first. Let me do one more absolute value. Let's say we have x minus 3 is, I'll do a greater than 1. We'll do greater than or equal to this time. 3. Okay. So once again, we got to get absolute value by itself. It already is, so that's good. So then we think about what absolute value means. Now this time we're saying that the absolute value of something is bigger than 3. That means farther away from 0 than 3. So if you think about, get a quick picture in your mind, here's -3 and 3. That's where the absolute value, that's where the distance from 0 is 3. So if the absolute value of this is bigger than 3, that means it's going to be out here and out here. So we have to describe that. So x minus 3 would live in this area right here, which would be less than or equal to -3, or x minus 3 would be in this area here, which would mean it's greater than or equal to +3. So then I just solve these two. So I add 3 to both sides, I get x is less than or equal to 0. Add 3 to both sides, I get x is greater than or equal to 6. So if we were to graph that, here's 0, 1, 2, 3, 4, 5, 6, there's 6. So if it's less than or equal to 0, there'd be a solid dot here and that way. And if it's greater than or equal to 6, there'd be a solid dot here and go that way. If we were to write this with interval notation, we would say that this would be -infinity to 0 with a square bracket, and this would be square bracket on 6 to +infinity. Another note with x, y, z, when you're graphing them, make sure you draw the arrows all the way out to the end. It doesn't really matter how long you draw the arrows, but for x, y, z, it'll mark it wrong if you don't draw the arrow all the way to the end of the graph that's on that they give you. So that's another important note. All right. Let me know if you have any other questions.